we will go to our second presentation from University of Nevada, Reno. Dr. MOUSTAFA is going to talk on shake table testing of precast UHPC bridge column with ABC seismic connection. Dr. MOUSTAFA?
So this is, one of the several projects, like we have been doing here at UNR on ultra high performance concrete columns. So some of these projects we have used the ABCTC before, to explore some of these concepts. Then we later on switched into buildings, and we got some funding from the ACI to explore UHPC columns for buildings as well. And we are trying to get back to bridges and push this further. So the title of this project is the shake table testing of a full precast UHPC bridge column with an ABC connection, seismic connection. So I have two PhD students working on this. Alan is the main student on this project, and he's focusing on the structural performance of the columns when we do the testing. And we have Milana, who is working on the material selection, exploring the different types of UHPCs to see which one we will pick moving forward. So we got some, collaboration ongoing with Kurtaf UHPC, and I will mention later on in a few minutes why we specifically, are going with Kurtaf for this project. So the reason we started looking into, UHPC full structural components in general is motivated by the fact that many of you have been, who are aware of the UHPC in the US market, who have been using a lot of UHPC connections. The ABCTC has did even a lot of work on this area with our own ABCTC non-proprietary UHPC mixture for connections. So the number of projects is exponentially increasing. There is more vendors. There is bigger, interest in non-proprietary mixes. So with all these things, you can see that there is an exponential growth in interest and the number of projects using UHPC in the nation. So this motivates, a lot of entities and institutions to take UHPC to the next level. So if we take the Federal Highway as an example, they have been focused on full precast girders. They are trying to push now for what they call it the ultra girder at up to 300 foot span. While this has its own transportation challenges and so on, but at least using UHPC can make these, doable at this point. So the Federal Highway is pushing, in this side. There are other places around the country that are looking at UHPC piles. In Malaysia, actually, they even already have built several columns that use, several bridges, that uses full UHPC U-girders. So the full structural UHPC component is happening and is coming. So with this in mind, what we wanted to do at UNR, we started looking at the columns specifically. So based on some preliminary investigation that we did in the past, when I started, my position here at UNR several years ago, we start looking into replacing conventional concrete columns with UHPC columns. What would be the benefits for bridges, for tall buildings? In fact, some of our recent ACI projects that we just completed looked at full-scale, slender UHPC columns. These ones, is from a different project. That's not ours. That this is, actually composite columns. But we did full UHPC columns, and we studied slenderness and stability issues for UHPC. So in general, we wanted to pick on UHPC columns. So focusing on these columns, our goal has been, or what we started at UNR is to focus on replacing normal strength concrete columns with UHPC for every application that we can benefit from. It's specifically bridges, since this is what we are talking about today. This could have, the higher durability that we get from the UHPC will lead to a longer service life and minimal maintenance cost, which is a big deal these days, for longevity and 75 to 100 years, service life, as opposed to 20, 30 years as in the past. For harsh environments, many of the bridges are in coastal, cities or something. These coastal structures can benefit from UHPC because this, have longer life. The higher strengths, if we properly use it, and this is, I would say, our main focus at UNR, is, how to redesign or rethink, the design philosophy so that we can have more compact cross-section, smaller cross-section. In a precast world, this means, faster production, lighter transportation, and lighter structural components. So it has its own benefits that all tie back to ABC as well. So we start looking into, different columns, as I said, slender UHPC columns, for instance. I'm just using two examples here. And an exploratory project that we did using some ABCTC funding several years ago, 4 years ago, we start looking into replacing full normal strength concrete column with UHPC ones. So I would just, for the next few minutes, I will recap what we did back in 2018. That's 4 years ago now. Thanks to the ABCTC, like we were able to explore this, like a new concept of having a full precast, like UHPC column. In this project, it was not precast. It was just, like small columns. I call them sometimes even baby columns. They were only like 10 inches or so. And everything was UHPC. It was cast in place. So I take the precast back. But, like it was exploratory in the sense that we wanted to see if we were to compare this with normal strength concrete, if we use high strength steel inside the columns so that we get the best out of the steel, the best out of the concrete, what we could get in terms of the benefits, and apply this for, like seismic columns in a general way, because what applies for seismic columns can be like used for conventional columns as well. So these are just some pictures from the construction. We had the outer footing with just normal strength concrete, but then we have the inner footing as UHPC. Again, we wanted to have continuity between in the steel of the like the reinforcement of the column, so that the entire column reinforcement is in UHPC medium, so that we don't have a weak surface, and this can enable us to understand the behavior of UHPC at failure. So we did, for this project, used Lafarge. At that time, 4 years ago, Lafarge, like used to have like one of their best, like I would say, like top of the line type of UHPCs. Now, most of the industry, especially, like the commercial UHPCs, they are not really pushing the boundaries for strengths anymore. The more applications we have, the more we know that, like having such 30 KSI UHPC is an overkill. So everyone is walking away, like from these high strength UHPCs. We are talking now 20, 22 KSI. That's the practical range that you will find for both commercial as well as non-proprietary UHPCs. But this is one of the older versions, which we're able to see up to 32 actually KSI in some of the columns that we had. We used grade 100 steel. So as I said, like we wanted to look at the best out of the concrete and the steel together. And we did a whole bunch of, tests. We explored for the first time the physical, plastic hinge behavior of UHPC columns. We compared conventional concrete to UHPC. For example, here, this is grade 60. We showed that you get literally double the capacity for the same cross section just by using UHPC. This is attributed to the fact that UHPC has the tensile, properties that cannot be overlooked anymore. It has its own contribution to the strength. It helps the concrete, even in compression, pushes a little bit further. It helps the steel, develop more strain hardening. So with all these features, you can get to double the capacity. So this is basically the motivation. So we wanted to come back, and pick where we left for bridge columns, and we want to, to explore now the behavior of full precast UHPC columns, and to, make this fully APC. Not only the columns are precast, but also we would like the connections as well to ABC seismic connections, and the footing could be conventional concrete in this case. So this are exploratory project. Since we started this project several months ago, we have a lot of potential, and I'm hoping, and I'm having excited discussions with the ABCTC UTC, so that hopefully in the next research cycle we will even expand this project further, and take it to the next level and collaborate with precasters in California to build actual UHPC precast columns. But this is not something to discuss yet. Hopefully it will be a future project. But as of now, we explored different options, and we see that there is a lot of potential in this. So what we are interested in doing is to have one UHPC, full UHPC column with ABC connection, and test it at one of our shake tables to understand the dynamic and loading, specifically under the dynamic loading. So we will explore different some of these objectives have been satisfied by now, because we are several months into the project. So we started already looking into different seismic connection options, and we have shortlisted which connection we are proceeding with. We did the same thing for the UHPC mixtures, as I will show in the next few slides. But then eventually we will design and construct a full precast, conventional concrete footing and a UHPC column that will be assembled using an ABC seismic connection, and we'll do a uniaxial shake table to investigate for the first time. Again, if you look at the literature, we don't see any of these, areas explored before, like the full dynamic behavior of a full UHPC column with ABC connection. This is something that's yet to be explored. So the tasks is a literature search, as we always do, and selection of the ABC connection that we wanted to explore in this project, which has been completed already. Second task, UHPC mixture selection and mechanical characterization. This is also a task that we have just completed. In fact, we have a journal paper actually publishing this. We were able to finish a paper and publish in 3 months or 4 months out of this, which I will show briefly as well. And then we, are now working on the development of the experimental program and specimen design to do shake table testing and eventually disseminate the results in a report, as we have always been doing. So in terms of the seismic connection, the two popular options when it comes to seismic, and you have heard about this from Dr. Petrona in the previous presentation. So we have the socket or the pocket connection, and we have the grouted ducts connection. While you have seen in the previous presentation from UNAR that, Dr. Petrona is pushing for the pocket connection, honestly, it is more appealing. It is much easier. I would personally pick the same. But if we look at for implementation, so far what Caltrans did in their ABC pilot project, they implemented the grouted duct connection. So we wanted, at least for this project, to go with something that has been implemented already. For one reason, that Caltrans has this connection already approved in their, ABC toolkit or whatever. And the other thing is that we have tons of research actually in this specific type of connection. In fact, what we did for Caltrans recently, we developed a non-proprietary UHPC version for this type of connection. The second task, so the takeaway from task 1 is that we are proceeding with the grouted duct connection, and this concludes the first task. The second task is that now that we have the luxury, of doing a full precast in column, or we will build the UHPC column ourselves here at UNAR, so we have the option to choose between which UHPC mixes we would like to do. So since, we always like to be, at the forefront of things, so we wanted to see what is the new or the latest in the UHPC world before we make our decision on proceeding with a specific type. So one material that's becoming very, popular these days, or not popular, available, I would say, is the carbon nanofiber enhanced UHPC. And the reason it's becoming more available is because, one of the vendors, Sientech, the Singaporean company, it is making a big strides now in the US. So we have it now available in the US market. It has been used already in several projects. So we have an ongoing collaboration with Sientech. We're able to, do a material characterization to see if this could be a potential candidate for columns or not. So we did, our own. What's new here is the nanofiber plug paste that you see here, which is everything is proprietary. This is a proprietary material. We did, I would say 300 cylinders. We tested them at different ages. For precast construction, it's always good to know what type of early strengths we are getting here. But what we did, because we are looking into seismic columns, we did a confinement study on the side, and this is the paper that we just published. So, we have done several cylinders with different confinement ratios, and we varied even the steel fiber ratio for this new generation of UHPC. We were able to get the full stress strain curves for all these to be able to get a sense. Is the carbon nanofiber really something that could benefit us at the structure level? The preliminary conclusion is that it's not. That's why we rolled out this option. The material is great. The carbon nanofibers has its own, benefits, but from a structural perspective, we didn't see really a big benefit to push for nanofibers for a full UHPC column. So at least we concluded this part of the study that maybe this is a great option, but not necessarily for full precast columns. So we went to the next options. You could have non-proprietary UHPC, which we have done as part of the ABC ETC already for connections, or what we can have is a semi-proprietary UHPC. And this is really appealing in a sense, is that unlike the non-proprietary UHPC, we cannot still scale this up, for a full column. The UHPC, I would say it's still emerging, so the non-proprietary ones, so it's not a higher end type of UHPC yet. So it is something that we are talking 15 to 16 KSI. If we want to explore seismic behavior, we better have something more robust. Then we can walk back, to lower versions of UHPC, but we didn't want to start with the fully non-proprietary UHPC so that we can still explore something more robust. So we decided to go with the semi-proprietary UHPC, and this is in the US. We have Kurtaf, one of the vendors here in the US, that provide this. So what do we mean by semi-proprietary? Is that the vendor will package their own magical mix, if you will, but you can use your own sand and cement. So you can locally, source your own aggregates and your own cement, and you can, have just part of the component, proprietary, and the rest will be just locally available materials. So that's what we did on the side. That's another project, another side study that we just concluded. We did different types of sands with different, sand grading, different even types of cements, and we looked at the effect of the different sands and cements, and we found out that even with the most fine, dry sand that you control and you are, have very good particle grading versus even very, unsieved, available sand from any of the quarries around here in Nevada, for example, we get very close results at the age, and we are talking here, 22 to 23 KSI. So we confirm this is a robust material for our purposes. We confirm that, or we are providing even some design guidance and construction guidance that different types of sands and cements can work. So we decided to proceed with this. So this concluded task 2 as well. And with this, what we will do next in the next few months is the traditional, UNR business that we do very well. So we are developing now, our experimental program. We are designing the column and the footing using this grout to ducts connection. This is the tentative test setup that we are going to use. This is, it will be the UHPC column, conventional footing with the grouted duct connection. This is, our shake table, and this is an actual picture from one of our old projects. This is not UHPC, and it's not even ABC project. It's just one of the conventional bridge columns that I tested in the past under long duration earthquakes. But this is to give you an idea what type of setup we are going to use. Once we do our shake table tests, we will do the data analysis and reduction. We'll make the data available as usual, through the ABCTC, and we'll have some deliverables, the design guidance, which we might have something now on the construction side as well, similar to what I've said, and the UHPC mix. If we are going with the semi-proprietary, what type of sand and sand grading to use, the connection, how to does the design, of the connection confirmed once we have the test results, so we can reassure the, the design community that whatever the guidance available for seismic connection can be valid for UHPC columns as well. So this will all be part of the ABCTC guidelines that we will develop from this project. We'll have the usual 5-minute video and a final project report and publication to summarize this. So sorry for rushing this. I just wanted to make sure, we stay on schedule, but if we have some time left, I would be happy to answer questions.
And thank you very much, Dr. Mustafa. You were right on time. We don't have time for more questions, but again, that's an exciting project. I'm sure that audience and whoever is watching has questions. If that is the case, please shoot your questions to Dr. Mustafa or us. We will connect you. You will receive the answers. Thank you again, Dr. Mustafa and Dr. Petrone from University of Nevada, Reno.